Section 1.5, quadratic equations. Some of you got the review for complex numbers, and some of you did not, depending on what section you were in. So if you do get a little caught here, let me know, and I can get you the information to go back through and learn about complex numbers. So the objectives, we're going to actually eliminate some of these objectives. So I'm going to take away completing the square from you, but we are going to hit these other objectives. Alrighty, so first thing we need to do is just what is a quadratic equation? So a quadratic equation, for some reason it doesn't want to turn red. A quadratic equation in x, it can be another variable, so we're going to say in x right now. And x can be written in standard form as a x squared plus bx plus c equals 0, where a, b, and c are going to be real number coefficients, and a cannot be 0, because if a is 0, then all we have is a linear equation, and we no longer have that quadratic. So a quadratic equation is also called a second degree polynomial equation. So you do need that second degree to keep it a quadratic equation. Also, another thing to point out here is that standard form. So standard form is usually when we take any kind of equation and we set it equal to 0. So we solve it so one side is equal to 0. The reason we do that is it actually helps with a lot of solving techniques later on. So we got a review on this. We're going to do it again. So zero product property. So to solve a quadratic equation by factoring, we apply the zero product property, which states that if the product of two algebraic expressions is 0, then at least one of the factors is equal to 0. Meaning, if I had a times b equals 0, so a and b can be an expression, so it could be a binomial. It also could just be a variable, but we have a times b equals 0 means either a equals 0 or b has to equal 0, but one of them has to be 0. So if I had something like 2x plus 3 times x minus 7, and that was equal to 0, what that tells me is that either 2x plus 3 equals 0 or x minus 7 equals 0. The nice thing about that is that I can sit here and go, well, either this binomial is 0 or this binomial is 0. So if I just solve for x, what it's going to give me, it can give me two solutions to this quadratic here. So if we expanded that, that's a quadratic. It helps me find my solutions. We're going to first solve quadratic equations with factoring. We're also going to use quadratic formula a little later. So factoring is really nice because sometimes quadratic formula isn't the best option for us, and factoring is the easiest and best option. You'd especially see this in pre-cal. There's a lot of times in pre-cal, factoring techniques work better than trying to use quadratic formula. So if necessary, rewrite the equation in standard form. So whatever our quadratic equation is, we will first want it to be in standard form. Anytime you try to solve a quadratic, doesn't matter if it's by factoring or if you're doing quadratic formula, you want it to be set equal to 0, so you want it to be in standard form. So we're going to move all non-zero terms to one side and leaving the other side equal to 0. At that point, we're going to factor completely, if we can't factor at all. And then we apply the zero product principle to each factor to obtain a variable equal to 0. And then you always want to, we're going to solve the equations that we get in step 3. So each one of those factors, we're going to solve them for x or y or whatever the variable is. And then we want to check our solution. So we should always be checking our solutions. I'm going to do it like once or twice, save time, but you should always be checking. So let's say we want to solve 2x cubed plus x equals 1. Let me give myself a little extra space here. Okay. So our first step is we want to rewrite in standard form. So a lot of times we hear this being called set equal to 0. So 2x squared plus x equals 1. So all we have to do is if I subtract 1 from both sides, I end up with 2x squared plus x equals 1 equals 0. So now I have my new equation that I want to work with. So my equivalent equation. Our next step is to factor. And we just want to factor that standard form because otherwise whatever factoring we do is not going to really help us. So we have the 2x squared plus x minus 1 equals 0. We're going to take a little bit more space than what I have right here. So we would have to use AC method. So my A is my 2 and my C is my -1. So my AC is -2. So if you remember, I need two numbers, P and Q, whose product is 2, but when I add them together, I'll get that middle term. So we just have x there, so it has a coefficient of 1. So very easily we'd see that, well, 2 times -1, if I multiply those together, I get -2. And if I add them together, I end up with a 1. So those are my two factors. So remember what we do is we split that middle term with them. So we have 2x squared, and now my x is going to just be 2x minus x minus 1. If I do groups here, my first group, I have 2x squared plus 2x. I can factor out 2x, leaving behind an x plus 1. And then here we have a -x, -1. We can factor out a -1, which will leave behind an x plus 1. Still all equal to 0. So then I can factor out my x plus 1, and that's just going to leave behind the 2x minus 1. Sorry, that should have been a plus there, equals 0. So we're going to use the 0 product at this point. So we have two factors here. We have x plus 1 is one of them. So if that is 0, then x times 1 times x plus 1 times 2x minus 1 would equal 0. Or the 2x minus 1 has to be the part that equals 0. So the step we're just going to solve for x. So we have the x plus 1 equals 0. Well, that's just going to be x is equal to -1. So that's one possible solution. Try to put this in here. So I'm going to put it here on the side. So we do the 2x minus 1. That we'd have to add the 1 to the other side, then divide by 2. So my other solution would just be the x is equal to 1/2. So it looks like my solutions are, we start with the smallest first, so -1, and then the next largest number. So just a reminder, before we're even done, the stuff we're going to kind of skip over sometimes, but you should check to make sure those answers do work. What you want to do is you want to check with the original equation before I started messing with anything, because if I made a mistake here in this step when I wrote it in standard form, I might take my solutions and they might say that I'm right, but I'm wrong. So we want to go back to the original. So we're going to x equals -1. If I plug that in there, I get 2 times -1 squared plus -1 equals 1. So that is 2 times 1 minus 1 equals 1. So we see we end up with 1 equals 1. So this is a correct solution. If x was 1/2, then I have 2 times 1/2 squared plus 1/2 equals 1, which is going to be 2 times 1/4 plus 1/2 equals 1, which is going to be 1/2 plus 1/2 equals 1. And we end up with 1 equals 1 again. meaning this is also was a correct solution. So we do have the correct solutions up here. All right, so we'll make so many steps on here later on. Take a moment on your worksheet and work through A and B. Just gotta make sure I fixed A here. Okay, yes, they should both work now. Okay. So starting with A, A is x squared minus 5 equals 4x. So the first thing I'm going to do is I'm going to subtract that 4x. So then I have to have x squared minus 4x minus 5 equals 0. So now we got in standard form. So now we just have to factor. So I need, as a reminder, two numbers that multiply to give me the minus 5, because we're doing a reverse FOIL here. And I need two numbers here that are going to multiply to give me the minus 4. So my options would be minus 5 times 1, because if I add those together, minus 5 plus 1, I get minus 4. So I know my factored form is just going to be x minus 5, x plus 1 equals 0. So we know that either the x minus 5 has to be the 0, or the x plus 1 has to be the part that equals 0. So if I solve those, x equals 5, x equals negative 1. So my solution, our solutions, are going to be x is equal to negative 1 or 5. Okay, and if you wanted to, you can go back and check both of them. Just mentally, I'm checking them quick here. 2, 1, yeah, they work. All right, so B is going to be a little bit more work, just because we have to do a AC method again. So in this case, you could do one of two things. You could subtract 3x squared, but we don't like that negative out front. You could just subtract your 11x and add 10 on the side, and then subtract 11x, add 10 on the side. And then we ended up with 0 equals 3x squared minus 11x plus 10, which that's okay. It doesn't matter which side the negative is on, just one side is your quadratic and then your negatives on the other. So AC method, my AC is going to be 3 times 10, so I'm going to get 30. So I need two numbers whose product is 30, but whose summation is going to be negative 11. So we need two numbers that are going to give me a positive product, but add to something negative, so I need two negative factors. Well, negative 6 and negative 5 twice. Because negative 6 plus negative 5 will equal negative 11, but multiply give me positive 30. So remember, we break up that middle term. So we have 3x squared. And instead of minus 11x, now we have minus 6x minus 5x. And if you wrote those, the minus 5 first and the minus 6 first, matter, that should work out in the end. So we're going to do group. So 3x squared minus 6x, we can factor out a 3x, which is going to leave behind x minus 2. Here we have a negative 5x plus 10. So if I factor out a negative 5, then I'm going to get a positive x minus 2, because 10 is divided by negative 5. Don't forget that this is still equal to 0. So we get x minus 2 factored out, leaving behind a 3x minus 5. So either x minus 2 equals 0, or 3x minus 5 equals 0. So we get either x is equal to 2, or x is going to be equal to 5 over 3. So my solutions would be smallest first, so we'd have the 5/3 or 2. Okay, so sometimes we will have a middle term missing, so we will have something though. Essentially, it will be a square, and it's equal to a number. Quadratic equations of the form u squared equals d, where u is the algebraic expression and d is the non-zero real number, can be solved by the square root property. So if you remember, we said if I take 3 squared, that equals 9. And if I take negative 3 squared, that equals 9. So if I have a square root of 9, technically I have 2 solutions. I have either 3 as a solution or negative 3 as a solution. So what we're going to have is that if u squared equals d, there's 2 choices that u can be. U is either the square root of d or the negative square root of d. So as an example, if I had x squared was equal to 9, we're saying is that x would have to be the negative square root of 9 or the positive square root of 9, or in other words, x is negative 3 or 3. So equivalently, a lot of times what we do is instead of writing the 2 solutions like that, we say, well, if u squared equals d, then u is equal to plus or minus the square root of d. Or in this case, x is equal to plus or minus 3, or the square root of 9. So remember that u doesn't have to be just a variable, doesn't have to be just x. It could also be like a binomial, as long as something is squared. All right, so we can use the square root property. So usually you're using the square root property when your x term is missing. We have a 5x squared. We don't have an x term in the middle, so we have 5x squared minus 45 equals 0. So what we want to do is we want to make it look like something like a u squared equals e. So the first thing I'm going to do, let's add 45 to both sides. Well, now I have a 5x squared equals 45. Well, let's do one more thing because I don't have a u, like my u squared, I don't have something squared by itself. I have 5x squared. So I'm going to divide both sides by 5. And I'm going to end up with x squared is equal 9. So something we've already seen before. Okay. In this case, we could solve this by saying, well, then x has to be plus or minus the square root of 9, or x is just plus or minus 3. All right, so this one's going to look very similar, except we have plus 45 now. I'm writing that again. So that means we're going to subtract 45 to try to get that by itself. So we're going to get 5x squared equals minus 45. Divide both sides by 5. We're going to get that x squared is equal to minus 9. I want to put that in a box. I just want to say we're just using this little section right here. So x squared is equal to minus 9. That means that x is equal to plus or minus the square root of minus 9. So if you're looking for real solutions, or you're looking for complex solutions, so you want to check your homework on this one. What it's asking you for. It's asking for real solutions or complex solutions. Real solutions, we can't do the square root of a negative. So we'd have no solution. In complex solutions, we know that the square root of -9 is really I square root of 9. So what we have here is actually x is equal to plus or minus I square root of 9, or x is equal to plus or minus 3I. So one thing to be careful of, do we have complex solutions or only real solutions? So worksheet number 2, you have x squared equals 8. So bear in mind, you still have to simplify if you have radicals. And then you have 3x squared plus 5 equals 0. And we are going to be looking for complex solutions. Look at the complex numbers. Okay, so like I said, we'll have complex numbers here if needed. So we have x squared is equal to 8. We don't have to do anything special here. We already have the setup of u squared equals d. But what we know now is that x would have to equal plus or minus 8. So technically right there we have our answer. But we'd like to simplify answers. So if you remember, 8 is just 2 times 4. So this is really can be just written as x is equal to is equal to plus or minus the square root of 4 times the square root of 2, or that x is just equal to plus or minus 2 square root of 2. So if you're doing this for homework, that's what your answer should look like because it likes simplified answers. All right, so B will be complex solutions. We're going to subtract the 5 first. And we'll have 3x squared is equal to minus 5. Then we divide by 3. We will have x squared is equal to -5/3, meaning that x is going to be equal to plus or minus the square root of a -5/3. So if you remember, that's the plus or minus, so square root of 1 times a square root of 5/3. So this is really just saying that x is going to be plus or minus I square root of 5/3. And we can't reduce that one any further, so we'll leave it as is. So we're trying to keep exact solutions that are simplified. All right, so we got quadratic formula here. So quadratic formula actually comes from completing the square. So they're really kind of, I want to say interchangeable. There's are things knowing completing the square is good for, but it's usually beneficial to learn that just before you need it. But quadratic formula, if you ever did complete the square, that's actually where the formula comes from. So completing the square is a process that helps us solve for x when we have a quadratic and standard form. But what ends up happening is that if I just had something that was ax squared plus bx plus c equals 0, and I used completing the square to solve for x, the formula that I would end up with is a negative b plus or minus square root of b squared minus 4ac over 2a. If there is one formula that you probably should have memorized, it's going to be this formula. Okay. Oops. There we go. Got myself in the wrong place. So we're going to run through using quadratic formula on these right here. So as a reminder, we have to have something of the form ax squared plus bx plus c equals 0. Quadratic formula says that my solutions to this quadratic, my x values are going to be minus b plus or minus square root of 4 square root of a squared, b squared, minus 4ac over 2a. Trying to write the wrong thing there. But we'll do a first. So we're going to write these over here. So a, we have 11x minus 10 equals 3x squared. So this is something we already had and we found an answer to. So we're going to rewrite it so it looks like ax squared plus bx plus c. So before we did that, we'll subtract the 11 and add the 10 to both sides. So we ended up with 3x squared minus 11x plus 10 equals 0. So like I said, this is something we already seen solutions to. We're going to do it again with quadratic formula. So my a will be the 3, my b will be that negative 11, and my c is going to be that positive 10. So all we have to do is just fit that all into the formula. So x is equal to minus b is negative 11. So if b is negative 11, minus b would be positive 11, plus or minus the square root of b squared, so negative 11 squared. Make sure the negative gets squared, because this b squared term or b squared component should always become a positive. Minus 4 times a, which is 3, and c, which is 10. And all this is going to be divided by 2a. And we said a was the 3. So this is 11 plus or minus 121 minus 4 times 120 over 6. So that's going to be 11 plus or minus the square root of 1 over 6. Make that fit in a little better. So the square root of 1 is just 1, so this is 11 plus or minus 1 over 6. But going back here, that means I have two solutions. I have 11 minus 1 over 6, because it's a plus or minus, or I have x is equal to 11 plus 1 over 6. So if we do this should be 10 over 6, or 5/3, which was one of our solutions. If I have the plus, that is 12 over 6, which is equal to 2, which was my other solution. Oops, that's too big there. These are my two solutions, would either be the 5/3 or x is going to be 2. Like I said, this is one we had already seen an answer to. Okay, so we're going to do b next. Let me make myself a little extra space here. Okay, so b, we'll start up here. So b, we already have this in the form we need it. Send that up a little bit. Let me write this right down here because I remember my camera doesn't show up right here. We are going to have, I have the room for this, b. We already have 2x squared plus 2x minus 1 equals 0. So my a is 2, my b is 2, and my c is negative 1. So remember, these are supposed to be coming from a is from the x squared, b is from the x, and c is that constant. So we use quadratic formula again. Minus b, that's minus 2, plus or minus the square root of b squared, which is 2 squared, minus 4 times a, 2, and c, which is negative 1, divided by 2a, and a is 2. So we get minus 2, a little more space there, minus 2 plus or minus the square root of 4 plus 8. all over 4. So this will end up being minus 2 plus or minus the square root of 12 over 4. So if we simplify the 12 is just 4 times 3. So simplified version of that would just be 2 square root of 3 over 4. So I can pull a 2 out of the top, and I have 1 plus or minus the square root of 3. I can pull a 2 out of the bottom. So my answer will be 1 plus or minus the square root of 3 over 2. And if we're going to keep this as there's ways we can write this. We could leave it like this and just have it 1 plus or minus the square root of 3 over 2. Or we can find an approximate answer. So in that case, we just stick in our calculator. Okay, bring my calculator back here. We would have the 1 plus square root of 3. Square root of 3 divided by 2. And that will end up being, let me write the negative first. Let me do 1 minus square root of 3 over 2, because that's going to be the first one we're going to have. So negative 0.366 approximately. And my other solution, if I have 1 plus square root of 3 over 2, is going to be 1.366. So sometimes you'll end up with 2 rational solutions like we did here in A. Sometimes in B, you're going to end up with irrational solutions like we have here. And then C, I believe C is our complex solution. Let's see here. So if I do C now, I'm going to erase A so I have room for C. If you still need it, just pause the video. Let me put my quadratic formula back here. So with C, we would have 3x squared. If we subtract, we'd have that 4x over here plus 10. So what we see here is that if I fill in my formula, my b comes from the middle. So minus b is negative 4. So we have plus 4 plus or minus the square root of minus 4 squared minus 4 times a, which is my 3, times c, which is my 10. Divided by 2a, so 2 times 3. So we're going to have 4 plus or minus the square root of 16 minus 120 divided by 6. So we're going to have x is equal to 4 times negative 104. Right, just going to check something here quickly. 4 times. Okay, so we just need to simplify that. Okay, so 104, put it up here. That's actually going to be 8 times 13. That's what I need to check out. This can be divided by 6. So we'll have 4 plus or minus. We have that negative here. So remember that negative can come out as an I. So then I'm just left with the 104 here. So keep going this way. And the 104 will simplify down to, like I said, if it's, oh, we don't need 8, we need 4. So if I have 104, that has a square in it of 4. 4 and 26. So if I were doing a square root of these, that means 104 is actually just 2 square root of 26. That's what I was trying to get at. So we would have 2i square root of 26 divided by 6. All right, so usually we don't write approximates when we have the I in there. We leave it like this, much easier. We do still need to simplify though, because everything here is divisible by 2. So I can factor a 2 out of the top and the bottom, leaving me with 2 times 2 plus or minus I square root of 26. And on the bottom, I'll have 2 times 3. The 2's will cancel because they're the same factor. We have 2 plus or minus I square root of 26 divided by 3. And I believe in your homework is willing to take it in this direction. So the square root of 26 followed by the I. So you take a moment here and do these quadratic formulas. Or use quadratic formula for these. There are maybe other techniques you can use, but I want you to try to use quadratic formula and take each one of these A, B, and C, and solve it with that quadratic formula. Like I said, don't try to use other methods because the point is to practice with the quadratic formula. Okay, so just a reminder, ax squared plus bx plus c equals 0. And if we have that, that means x is going to be minus b plus or minus the square root of b squared minus 4ac divided by 2a. So if I look at a here, we have 2x minus 5 squared equals 27. So if I take this is a square. If you remember the property, we get 2x squared plus 2 times a, which is my 2x, times b, which is my minus 5, plus the b squared, so the 5 squared equals 27. I'm just expanding a square. So we have 4x squared minus 20x plus 25 equals 27. So if I subtract the 27 from both sides, now I'm going to have 4x squared minus 20x minus 2 equals 0. All right. So if we take this and we put this in quadratic formula, we get x is equal to minus b. So we got a negative 20 here. So we're going to have positive 20 plus or minus the square root of b squared. So 20 squared minus 4 times a, which is 4, d, which is negative 2, divided by 2a. And we said a was the negative 2. This is 20 plus or minus square root of 400 plus 36. Thirty-two, sorry. Minus 4. Okay, so if I keep going with that, that means that x is going to be 20 plus or minus the square root of 432. 432 divided by, is it 16? Yep, 16. Negative 4. So if I take this 432, it's 16 times 27, so that will simplify into 4 divided by the square root of 27. So we're going to 27 back, divided by -4. And once again, everything is divisible by a negative, well, a 4. Another way you can look at this is that you can say, well, that's 20 divided by 4 plus or minus 4 square root of 27 divided by 4 or -4. You can break it up like that. So what you'll end up seeing is that we'll end up with a -5. 27, yes, plus or minus the square root of 27. Because it doesn't matter if it's negative, it still turns into a plus or negative, a plus or minus. Just checking something here because I feel like I got a negative that I wasn't supposed to get. It's 4AB. No, we're good. All right, so if we do B now, B is 2x squared plus 4x minus 5 equals 0. So we already have our A, B, and C. So we will have x is equal to minus b, so -4 plus or minus the square root of 4 squared, minus 4 times a, which is 2, c, which is -5, divided by 2a, so 2 times 2. So we'll have -4 plus or minus 16 times 20, no, 40. Sorry, I don't know why the 0 didn't write down. Maybe I just didn't do it. And this is all divided by 4. So we're going to have x is equal to -4 plus or minus, make sure this is working out right, 16. Yeah, okay. -24. So x is -4 plus or minus, so 24. This is going to be I square root of 24. We just need to simplify the 24, which simplifies into 4 and we can multiply by, sorry, break down 24 into 4 and 6. So I don't know why I need my calculator for that. We're going to have 2i square root of 6 divided by 4. And everything here is divisible by 2. So x is just going to be -2 plus or minus I square root of 6 divided by 2. All right. And then C, it's going to seem a little weird. Actually, going to go pretty easy though. So with C, we have x squared minus 10x. This my way. Sorry, you didn't see that, but I have something on my way on my screen. 10x. All right. I apologize. Take a moment, pause, record this, because I'm going to have to get off and come back on to make this work. Apologize, the annotation tool tends to start glitching when I've used it too long. So C, that is going to be x squared minus 10x plus 25 equals 0. So I have A, B, C. So we have minus B, so B is -10, so 10 plus or minus the square root of -10 squared minus 4 times A, which is 1, because there's an invisible 1 here, and C, which is 25, divided by 2A, which is that 1. So what you're going to see here is we're going to get 10 plus or minus the square root of 100 minus 100 divided by 2. Meaning I really only have 10 plus or minus the square root of 0 divided by 2, which means that x is just going to be 10 divided by 2, and x is going to be 5. So you may have noticed that this one is actually a perfect square. So this is actually x minus 5 squared equals 0. So in this case, we only get one solution. So on occasion, you will have you'll only have one solution. We'll only have one solution, or I mean, we'll have two solutions, either two solutions or one solution, with the exception of the real numbers. Sometimes we have 0 solutions. But this is going to lead us to the discriminant. So we can find the solution for a quadratic equation of the form ax squared plus bx plus c equals 0 using the quadratic formula. The discriminant is going to be this part right here. So the part under the square root is going to control how many solutions we have. So if we're in the real numbers, and this is going to be a negative under the square root, we end up with no solution. If we're in the complex numbers, then that would give us an I. If this b squared plus minus 4ac was positive, that tells me I have two solutions. And when it's 0, that tells me I have only one solution. I do not use this a lot, but some people do. That's why we're going through it. So if the discriminant is positive, there will be two unequal real solutions. If the discriminant is 0, there will be only one real solution. This one can also be a complex solution. So it will be either two unequal real solutions or two, depending what it is, it will be unequal, there you go, complex solutions as well. If the discriminant is 0, you will have one real solution, but technically because it's a real solution, it's going to be a complex solution as well. And if the discriminant is negative, there is going to be two imaginary solutions and no real solutions. Just something to note here that when we're talking about real solutions, complex solutions, if real solutions exist, they are also complex solutions. They're still a complex number. The only thing where things really change is when it's going to be less than 0 or negative is for the discriminant. Then we will have two complex solutions or imaginary solutions, but we'll have no real solutions. All real solutions are complex solutions, but not all complex solutions are real. We just want to use the discriminant and determine what the number of solutions. So A, B, C. Discriminant is just b squared minus 4ac. So that means we're going to have negative 7 squared minus 4 times 2 times negative 4, which is going to be 49 minus 32. So we'll end up with 17 here. Times shoot. Oh, negative 4. It's going some here, but it didn't seem right. Minus and minus, so that should be a positive. There we go. Now that's working. So then we'll have 4, 5, 6, 7, 8, 81 as the answer. So the discriminant, not determinant, positive, we have two real or complex solutions. So take a moment here and just determine how many solutions that we would have in the type of solution from A and B. So just remember, this is my discriminant. Discriminant is going to be b squared minus 4ac. So a, b, c. So here we'll have 4 squared minus 4 times 1 times 5, which is 16 minus 20, which is going to be minus 4. The discriminant is negative, so we have to do the square root of a negative, meaning we have two complex solutions. But we don't have any real solutions. So here we got 9x squared plus 12x plus 4. So my b is going to be 12. So 12 squared minus 4 times 9 times c, which is 4. Okay, so that one I definitely need to put in my calculator. 4 times 9 times 4. So we're going to end up with 144 minus 144. Well, that equals 0. The discriminant is 0. So we have one real, or you can say complex, still complex number, solution. Okay, so we have left some application problems. So the formula, the formula P equals 0.01 a squared plus 0.05 a plus 107 models a woman's normal systolic blood pressure. So I believe that's when your heart relaxes, if I remember right. P at an age A. So P is your pressure, A is your age. Use this formula to find the age to the nearest year for a woman whose normal systolic blood pressure is 115 millimeters of mercury. So we know P. So we can put in 115 is equal to 0.01 a squared plus 0.05 a plus 107. Now, because I know quadratic formula, this is something I can actually solve. Because if I just subtract this from each side, that 15, then I have 0 is equal to 0.01 a squared plus 0.05 a minus 8. And this is something we can use quadratic formula on because we have that variable squared, and a squared, its coefficient is 0.01, which is a. The coefficient here on this a is 0.05, which is my b, and this 8 is my negative 8 is my c. So if x is equal, a, because a is my variable, is equal to 0.05 negative 0.05 plus or minus the square root of 0.05 squared minus 4 times my a, which is my 0.01, times my c, which is negative 8, all divided by 2a, which is 0.01. All right. So I'm just going to do this. 0.05 squared minus 4 times 0.01 times -8. Okay, 8 is equal to -0.05 plus or minus the square root of 0.3225 divided by 0.02. So there are two possibilities for A. A is either -0.05 plus or minus the square root of 0.3225. I'd put this all in parentheses in your calculator, divided by the 0.02. Or A is equal to the -0.05 minus the square root of 0.3225 divided by 0.02. All right, so let me put these in. -0.05 minus the square root of 0.2335 okay. So in this case, the answer would be this person would have to be negative 30.9 years old. That doesn't seem very likely, so this is probably not the right answer. Now, if you look at the other case with the addition, this one, we get somebody who is 25.9 years old. So the age of the woman is 25.9 years. So if a woman walked in with that kind of blood pressure, we would assume that's probably what her age would be, is really close to 26. Doesn't mean she is, what the model would tell us. So use your worksheet here. So a stone is thrown from a 100-meter cliff at an initial speed of 20 meters per second at an angle of 30 degrees from the horizon. The height of the stone can be modeled by h, which is height, is equal to -4.9 t squared plus 10t plus 100, where h is the height in meters and t is the time in seconds after the stone is thrown. This is your gravity is actually what this is. We want to determine the time in which the stone is 50 meters from the ground and determine the time in which the stone hits the ground. Okay, so for A, we have the stone is 50 meters from the ground, so that's 50 is equal to -4.9 t squared plus 10t plus 100. So I can rewrite that so that if I just subtract 50 from both sides, that's 0 equals -4.9 squared, or sorry, 4.9 t squared plus 10t plus 50 now. So A, B, C. So that means E is going to be -10 plus or minus the square root of 10 squared minus 4 times -4.9 times 50 divided by 2 times -4.9. Okay, so that will be 100 minus 4 times -1.4 times 50. We are going to get -100 plus or minus the square root of 180 divided by -9.8. We know we have solutions here. T is equal to -10 minus the square root of 180 divided by negative 9.8, or T is equal to -10 plus the square root of 180 divided by negative 9.8. So we have to look at both of these, or if you look at them, you might realize which one would work. So we're looking at time. As time goes ahead, right? The stone is falling, so the positive time should be the correct time for us. So I'll say again, put parentheses around the top if you want this to work out correctly. So here I'm going to get 4.38 seconds approximately. And here I'm going to get approximately negative 2.33 seconds. Like I said, the stone was originally 100 meters, so this is as time goes forward. So we know this would have to be the correct solution. So B is going to be a lot quicker because we want to know when the stone hits the ground. So 0 equals negative 4.9 t squared plus 10t plus 100. So that means t would have to be -10 plus or minus 10 squared minus 4 times negative 4.9 times 100 divided by 2 times negative 4.9. Oh, dang, I have to put that all in there again. So 100 minus 4 times negative 4.9 times 100. This is going to be negative t plus or minus the square root of 2060 divided by negative 8.9. So if you look at our two solutions, either it's negative 3.61 seconds for it to hit the ground, or sorry, I think I looked the wrong thing there. 5.5 5.65 seconds. So it's probably this one because, like I said, time's progressing forward. All right, because this wasn't from your homework, this is why I threw this one in here. The sum of the squares of the length of the legs of a right triangle equal the square of the length of the hypotenuse. This is Pythagorean theorem. If legs have length A and B, the hypotenuse has length C. So we know, like I said, by Pythagorean theorem, that A squared plus B squared equals C squared. So if I know this and this, I can use it to find C. So if you didn't realize this when you're measuring TVs, the figure shows the dimensions of a TV. We want to know the size of the screen. When they measure the size of the screen, it's actually that diagonal size. We should get 32 inches. It's a 32-inch screen. This is how they're actually measured. We have A, B, and we want to find C. So we have 19.2 squared plus 25.6 squared should equal C squared. So we get that other side. So what we end up with is that C squared is supposed to be equal to 1,024. So if you remember, technically when we solve this, that means C is equal to plus or minus the square root of 1,024. That means C is equal to plus or minus 32. So we just picked the one that makes sense, which is we don't want a negative measurement, that C is actually just going to be 32 inches. Oops, a minute here, something's having a glitch. All right, so your last problem, a garden plot is planned so it is in the shape of a right triangle. The legs of the triangle are planned to be x feet long and x plus 7 feet long. If the diagonal must be 20 feet long, how long are the other two sides? So using Pythagorean theorem again. So we have a garden plot looks like this. We have one side that's x, one that is x plus 7, and then this diagonal is going to be 20 feet. So we just have a triangle. We can figure out the other rest of the garden plot is, but we're really just focusing on the fact that we just have the triangle here. So by Pythagorean theorem, that means that this side, we're going to have x squared plus this side, because it's another leg, x plus 7 squared, should equal the hypotenuse, so that's 20 squared. So we have x squared is equal to, if we expand that, we should get an x squared plus 14x plus 42. 42 is equal to 400. Which means we have 2x squared plus 14x. And if I subtract this 100, we are going to have, second, 400 minus 32, negative 368. So we have A, B, and C, and we can use Pythagorean theorem. Not Pythagorean theorem, sorry, quadratic formula. So negative 14 plus or minus 14 squared minus 4 times A, which is 2, B, which is negative 368. This is all going to be divided by 2A, 2 times 2. Okay, so if we do the 14 squared minus the 4 times the 2 times the negative 365, that means we're going to get x is equal to negative 14 plus or minus the square root of 3,116, all divided by 4. We have two possibilities here. Either it's negative 14 minus the square root of 1,364 divided by 4, or it's negative 14 plus the square root of 3,116 divided by 4. So if you do negative 14 minus the square root of 3,116, second, I have some sort of glitch at my end. Oh, my stuff is glitching out today. Divided by 4. Then this is going to say that x should be a negative 17.5, or it's supposed to be a 10.5. 10.5 seems to make a little more sense because we're talking about the lengths of garden plots. So it's x, right? So the x is 10.5. So this side is actually 10.5. And this side, because we have that x plus 10, so that should be 17.5. So it should be 10.5 feet and 17.5 feet.